Hello, Professor and everyone. So for PQ3, I chose IBM SS for its easy-to-use graphical user interface. The data set to be analyzed in Descriptive and Predictive is the full data on COVID-19 year 2020. So this file was obtained from the highly informative COVID-19 statistics and research. The file structure is fairly simple. It contains date variable, location, and variables that provide daily counts of new recorded cases, newly recorded deaths, uh, total cases, total deaths. In addition to data for the entire world, there is data for 199 specific locations from Afghanistan to Zimbabwe, where at least one COVID-19 case has been reported. So first, I did was to convert the date variable to a format that SPSS statistics recognizes. Then I use the split file command to analyze data separately for each location. To do that, let's go to new and then syntax. Let's go to this, which I did earlier. Here, the split file command and a split file by location. So let's focus in a particular subset, which is Canada. We need to activate this data set first. So this is the code for the activation. You can also filter out all other locations just by changing this one, like United States, Japan, something like that. So let's go to our new data set, which only consists of the Canada cases here. Okay, since our data is ready, let's go to the descriptive analysis. I just chose two variables, total cases and total deaths. We can see here the mean. It provides a measure of central tendency. So for total cases in standard deviation, indicates that the number of cases varies wildly around the mean, and this suggests a significant variation in case counts. And for total deaths, indicates that the number of deaths also shows some variation around the mean. And for skewness and kurtosis, for total cases, the skewness is approximately 0.838, indicating a slight right skew, which is positively skewed. It suggests that there are relatively few days with a significantly higher number of cases compared to the majority of days. And for the total deaths is negative 1.039, indicating a more pronounced left negative skew. This total cases and total deaths suggesting a relatively normal distribution. However, this negative value, this one, indicates that the distribution is slightly flatter and has lighter tails compared to a perfectly normal distribution. So I included here a histogram using the chart builder, where you can find here this one. So this histogram visually conveys the increasing trend in COVID-19 cases as the pandemic progressed. We can have more analysis when we go to the time series modeling, which is the next one. Mm, so for the predictive analysis, since the primary goal is to examine and model the temporal patterns and trends in COVID-19 data over time, so I use time series analysis instead of a structural equation modeling to be able to produce this. time series. Let's go to analyze, forecasting, create traditional models, dependent, independent variables. The method should be expert modeler and criteria. Let's include outliers too. Continue and then OK. So this is the outcome, model description, model fit, model statistics, and series chart. So with 15 outliers fitted by this model, procedures expert modeler fits the observed data in the assessment of the residuals for autocorrelation. So the high statistics is stationary R squared. Value suggests a relatively good fit, but the significant, this one, this is the, it has a low p-value and it may indicate that there is still autocorrelation in the model's errors, which is something to consider for further analysis or model refinement. And then next, let's go to nonlinear regression analysis. We fit this model using an exponential function of the number of days. So yeah, this one. Iteration history, parameter estimates, correlation, ANOVA. So the model we fit has two parameters, B0 intercept, this one, and the B1 growth parameter that is raised to the power of time in days. This model also fits the data quite well. So the value of B1 growth parameter is approximately 1.200. So taking the ratio of the algorithm of 2 divided by the algorithm of this value gives us the predictive doubling time in days, which is approximately 3.8. So according to this model, the results mean that on average, new cases are doubling approximately every 3.8 days. So we have nonlinear regression analysis in the time series modeler. So let's see how the forecasts from the two models compare. Yeah, here we have a summarized case processing here. Case summaries. So to summarize, these both models forecast eternal growth, the number of new cases. But as we can see here, so for this last two columns are predictions and forecasts from time series for this one and exponential nonlinear regression models for this last column. Yeah, we can see here that this column of the exponential nonlinear regression model grow explosively. See, goes on millions and billions. So that's pretty much it. Thank you for listening. Bye.